Hello everyone, myself Nitin Kumar, Assistant Professor NIFTEM, welcomes you all in a training program on cold chain and logistics funded by GIZ Germany and jointly organized by CII and NIFTEM Kundli. Today we will discuss refrigerant, which is actually a media which flows inside a refrigeration system, absorb heat in evaporator and release heat in condenser. Refrigerants are the working medium which evaporates by absorbing heat from the cooling chamber and produces cooling effect. It contains carbon, fluorine, usually chlorine, and sometimes hydrogen, bromine, or iodine. In general, refrigerant may be referred as CFC chlorofluorocarbon, HCFC hydrochlorofluorocarbons, or hydrofluorocarbons. Sodium nitrite or potassium nitrite are generally dissolved in water to reduce the freezing point of water, and such water can be used for the applications of chilling or freezing. People were used to store the food for their future consumptions using ice harvested from mountain and stored in pit insulated with wood or straw. Refrigerants were discovered with the factor in mind like stability of refrigerant, durability, safety and environmental concern. So we can divide the generation of refrigerant in the following detail. In first generation, which is in the year of 1830 to 1930, whatever worked can be characterized under the first generation refrigerants like CO2, NH3, SO2, etc. In second generation refrigerant, the safety and durability is the primary concern like chlorofluorocarbon, hydrofluorocarbons, etc. In third generations, ozone depletions will be a parameter for the selections of refrigerants like hydrochlorofluorocarbon, NH3, CO2. In the fourth generation, which is 2010 onwards, global warming is the primary concern while selecting a refrigerant, and in this category one can choose zero or low ozone depleting potential refrigerant with high efficiency. Properties of an ideal refrigerant: low boiling point and low freezing point, low specific heat with high latent heat. Third point, high critical pressure and temperature, low specific volume to reduce the size of compressor. If the specific volume is less, that means amount per unit volume is high. High thermal conductivity of compact evaporator and condenser, non-flammability, non-explosive, non-toxic and non-corrosive refrigerants are better refrigerants. High miscibility with lubricating wire, this is the factor generally considered while there is a leakage between the seal or gasket and there will be mixing of oil and refrigerants. High COP, that is coefficient of performance in the working temperature range, compatible with leader requirement, very important while selecting a refrigerants, and availability and the cost of refrigerants is also one of the factor for easy handling, maintenance and long lasting. Numbering the refrigerants or the nomenclature of refrigerant. Suppose you go to the market for buying a refrigerant, the refrigerant comes with a name R12, R134A. Likewise, in this slide I have given an example that is R1234 ZE in bracket E, where R represents refrigerants which can be carbon fluorocarbon, hydrogen fluorocarbons or others. In this case, 1 stands for number of double bonds, 2 stands for number of carbon -1, 3 stands for number of hydrogen +1, number 4 stands for number of fluorine atoms in a refrigerant. ZE stands for isomeric designations if applicable, and capital E here is a confirmations if applicable like for trans or cis. For methane, ethane and propane, in the refrigerant are XYS, where X is the number of carbon atom in the chemical formula -1. In the methane series it is 0. because the formula of methane is CH4. So one is the number of carbon minus 1 equal to X becomes 0. The X 0 is known in a numbering for R12, R22, etc. Ethane series has X equal to 1 because there is two number of carbon atoms, and R114, R124, R134A, etc. are the examples of ethane series. In case of propane, X equal to 2 like R290, in where Y is the number of hydrogen atom minus 1 and Z is the number of fluorine atom. In case of geotropic and azeotropic mixture, the nomenclature is as follows. If X equal to 4, it shows that refrigerant contains geotropic mixture, while Y and Z are ordinary number. Components in this type of mixture have different boiling points. Mixture has a temperature. Glides means the difference between the bubble points and dew points of the mixture. Example of geotropic refrigerants are R407A, R407C. Bubble point we can define here the point at which the first drop of a liquid mixture began to vaporize, as well as we can define the dew point also. It is the point at which first drop of a gaseous mixture began to condense. Azeotropic mixture has homogeneous compound with a specific boiling point. This type of refrigerant has no temperature glide. Examples of azeotropic mixture are R502 and R507. In case of organic compounds, X is 6, such as 600 for butane. 600A is isomer of butane and it is called isobutane. Contains subgroup, that is nitrogen compound, oxygen compound, sulfuric compounds, hydrocarbon, etc. In numbering, Y and Z represent the subgroup and other within the subgroup. In case of inorganic compound like water, CO2, ammonia, the refrigerant can be nomenclated as R717 for ammonia, R718 for water, and R744 for carbon dioxide, so on. In case of unsaturated organic compound, the X equal to 11, such as ethylene R1150. Unsaturated propene compound are represented as X equal to 12, like R1270 polypropylene, while Y represent the number of hydrogen atom minus 1 and Z represent the number of fluorine atom. In letter after numbers, lower case represent the structure of molecule. For example, R600 butane and R600A isobutane have the same chemical formula, but they have slightly different properties as they have different arrangement of molecule, and one can verify the same from this picture. Capital letter represent the mixing proportions of different components like R407A, R407E. Have different mixture of refrigerant, that is R32, R125 and R134A. For example, R407A contains R32, R125, R134A at the ratio of 20:40:40, and R407C contains R32, R125, R134A in the ratio of 23:25:52. Now let's discuss the type of refrigerants. Refrigerant can be divided into several groups depend on their chemical composition. The first one is chlorofluorocarbon. Chlorofluorocarbons like R114 and R11 were discontinued as they were unsafe for the ozone layer and were eliminated in the year of 2000. Nowadays utilized as a part of outdated equipment with precautionary measures and also mostly used in centrifugal coolers. R12 is also being utilized for the air conditioning. R12 has very high environmental hazards and now replaced with R22. R11 is a fire resistance and a suitable refrigerant considered safe to use. Hydrofluorocarbons like R22, R123, etc. have lower impact on ozone depletions in comparison to chlorofluorocarbon, but they will be eliminated by the year 2030. Comprises of methane or ethane with the chlorine and fluorine have lower lifespan, contain lower amount of chlorine which results in lower ozone depletions. R22 is inflammable and safe, that's why widely used in air conditioning system. R123 can replace R11 to use in the radiating cylinder, cooling framework and ventilating applications. R401A is utilized as a retrofitting for R12 components used for the temperature requirement of -15 degrees centigrade and above. Hydrofluorocarbons. Chlorofluorocarbons replacement and cause no harm to ozone layer as they do not contain chlorine atom, has some effect on global warming potential. Hydrofluorocarbons break down into TFA can be accumulated in hydrologic cycle which can cause toxicity to the wildlife. Common HFCs used nowadays are R32, R125, R134A, R245CA, R245FA, etc. R134A is widely used as a substitute for R12 and R500. First hydrofluorocarbon introduced in refrigerants required no modifications in the equipment used for R22, but efficiency was 40% lower. That is mainly because used in a large system with over 250 kilowatt. No impact on ozone layer, but it has 1439 times more greenhouse effect compared to CO2. In case of R410A, which is azeotrope, has a marginal temperature glide and operation pressure requirement is double than R22. Higher heat transfer capacity compared to other refrigerant. R507 is the best alternative for R22 and R502. Has some qualities as R502 with non-toxicity and is inflammable. Fourth is natural refrigerants like ammonia is great alternative as natural refrigerant used in a refrigeration system since 1840s, and it has zero ozone depletion layer and global warming potential. Self-acylating gas as it is easy to detect as leak by smell of the ammonia, but at very low concentration the ammonia gas is very hazardous and its smell can cause panic. Because of its hazardicity, ammonia is only limited to industrial applications with still supervision. Carbon dioxide is available in large quantity and has no impact on ozone depletions, inflammable, very low toxicity. It required high pressure, that is 10 times higher compared to R134A or ammonia or R404A, but has very low efficiency. Plate freezer and multi-chamber blast freezer utilized with CO2 systems are found to have increase in efficiency and reduction in freezing time. CO2 is widely used in low stage of industrial cascaded system. Hydrocarbons. Refrigerants are the component of natural gas and oil. It's highly flammable, good environmental and thermodynamic properties, have broad range of boiling point, and utilized from air conditioning to cryogenic applications. These are the list of commonly used hydrocarbons like methane, ethane, propane, butane, isobutane, ethylene and propylene. Used in refrigeration system in beverage and ice cream, refrigerants, chillers 0.3 to 40 ton capacity in air conditioning unit, replacing R134A with propane can save up to 80% greenhouse gas emission. Gives us an idea about a refrigerant used in a different food industries like meat industries, milk and dairy industries, fish industries, fruits and vegetable industries, food distributions industries. From this slide, we may conclude that R404 stands number one in applications of these industries, followed by R22 and others. Contaminated refrigerants are substandard compound mixed with the refrigerants. Different from the refrigeration blend, can reduce the cooling efficiencies, increases energy consumptions, damage and reduce the lifespan of the refrigeration system. Contaminants like R22, R12, R40, R152A, R142B, etc. are found to be the mix in the newly filled cylinder of R134A. Other refrigerants like 410A, 404A and R22 are also found to be contaminated. Let's discuss a case study of a contaminated refrigerants, and I have taken this study from a company. Mars is a well-known refrigerator container service provider, had experienced 3 separate explosions of the compressor with no direct reason. Explosion occurs in the year 2011 in Vietnam and Brazil. It was found that between 30 March 2011 and 25 April 2011, all 3 containers went for maintenance and repair of a gas system at a repair yard at Vietnam. Material covered from the explosion was analyzed and R40 was found to be the contamination in the system. R40 was widely used in the past. Due to the high toxicity and flammability, it was banned and discontinued. R40 can react with the ammonia and produce trimethylammonium, which is pyrophoric substance, and ignites rapidly when comes in contact with the air. As a precautionary measures, must CMA, CGM and APL has drowned 842, 332 and 103 containers respectively because of the suspicions of a contaminated refrigerants. You can understand the severity of a contamination in the refrigerants. What next for refrigerants? Montreal Protocol at Rwanda held in 15th October 2016, an amendment was accepted to phase down hydrofluorocarbons, accepted by 119 countries including India. Countries have committed to reduce the production and consumptions of hydrofluorocarbons for 80% and more over the next 30 years. In India, hydrofluorocarbons like R404A and hydrochlorofluorocarbons like R22 are widely used commercially. With the acceptance of amendment, India has decided to ban the production and consumptions of these 2 refrigerants by the year of 2028. So the told store owners, refrigerant consultant, food letterer, etc. have to find the replacement of these type of refrigerant and have to start their migrations to alternative refrigerants. One of the replacement can be hydrofluoroolefins like R448A, which has a good efficiency and performance and global warming potential about 38% lower compared to R22 and R404A. Trials were carried out in USA and Europe. It was found that compared to R404A in low temperature applications, R448A consumes 3 to 4% lower energy. In medium temperature applications, it consumes only 9 to 12% lower energy. A company based in UK has developed R473A refrigerant, which is a blend of R23, CO2, R113, R125 in a ratio of 10:60:20:10, which has ASHRAE A1 class and has lower global warming potential of 1830 compared to R23, which is having 14,800 global warming potential, and R508 with GWP 13,396. It can generate low temperature up to -70 degrees centigrade, developed for new systems, but research is going on to make it retrofit to R23 systems. Next generation refrigerants and their applications. In this slide, I have listed down some of the refrigerant which can be the next generation refrigerant on the basis of their blend, boiling point, applications, and most important, ozone depletions potential and global warming potential one can go for the selections. This slide have a group of tetrafluoroolefin, tetrafluoroolefin, 1-in, hydrofluoroolefin, option. In the next slide, we do have HFC blend, different number of refrigerants. Industries linked with the production and utilization of refrigerant should move forward towards the natural refrigerant for the overcoming of the ozone layer depletions and global warming. It minimizes the use of hazardous refrigerants harmful to the environment. As the future regulations of the synthetic refrigerants will be very severe, there should be R&D for the utilization of natural refrigerants. Hydrocarbons can also be utilized with no or little effect on the environment. Blends of hydrocarbons can minimize their flammability, and with proper leak detection system, toxicity of the hydrocarbons can also be prevented. So in this module, we have discussed the nomenclature of refrigerants, the types of refrigerants, and the global warming potential and ozone depletions potential of the refrigerant used into the industries. In addition to this, what are the future refrigerants which are development stage. So in this module, we have discussed the nomenclature of refrigerants, the types of refrigerants, and the global warming potential and ozone depletions potential of the refrigerant used into the industries. In addition to this, what are the future refrigerants which are development stage. Thank you.